We have seen new model creation and defining materials in the earlier video. Now let us see the third step in the workflow, that is defining structural elements. Here the structural elements are nothing but beam, column and slab. First of all, let's define column sections. In Etabs, beam and column are nomenclated as frame sections. As discussed earlier, to define beam or column sections, select Frame Sections, click on Define menu, select Section Properties from the drop-down list, and then select Frame Sections. Then immediately it will pop up a window with the name Frame Properties. Under Filter Properties list in Type, the drop-down list can be used to limit the list of section shapes displayed in the Property Display area. This is the Property Display area. For example, if Concrete Rectangular is selected, then only concrete rectangular sections will be displayed. I'm making it as default again. Now let's see Filter. The Filter Edit box is used to limit the list to make a selection of the frame sections easier. Let's type the name of the frame in this box. Look at this, the sections has been filtered with respect to the name which we have given in the filter. Use Clear Filter button to restore the full list of frame sections. Next, find this Property Edit box. This box is used to locate a property definition in the long list of frame property definitions in the display area. Type the name of the property that which you would like to locate from this list. Type C in this edit box. Then it will locate the property starting with the letter C. The next is Import New Properties button. Click this button to access the frame property shape type form. Select the section shape from the drop-down list or click a frequently used shape type. Let me select the rectangular from the concrete. It will display the frame section property import data form. Use this form to specify a database of section types from which shapes can be selected for import into the model file. Then click on OK. Next is Add New Property button. Click this button to display the frame property shape type window. In this, select the required shape. Let's select rectangular. Immediately a window pops up with the name Frame Section Property Data. In this, we have to enter the details of frame section. Let's take an example. In this, we have to create a rectangular concrete column of size 450 by 300. First of all, enter the name of the section. Let's give the name as C450 by 300 for the easy identification purpose. Now we have to specify the material from the drop-down list. Here select the grade which we have defined in the earlier step. Here select the concrete grade which we have defined in the earlier step. Let's select M30. Click on this Modify Show Notional Size to display the time-dependent parameter form and can specify the notional size parameter for creep and shrinkage behavior. And also we can change the display color if it is required by clicking on Change here. Select the required color and then click on OK. We can add any notes or description to this particular column if it is required by clicking on this Modify Show Notes. Enter the description in this box and then click on OK. Now we have to specify the section dimensions of column. Enter the depth as required, that is 450 mm, and width as 300 mm, and then press enter. We can cross-check the section. In this window, there are two local axes which are indicating the directions in the cross-section. After giving section dimensions, click on Modify Show Rebar under Reinforcement. It will pop up a window with the name Frame Section Property Reinforcement Data. In this, first we have to specify the design type, that is beam or column. As currently we are creating column section, so select here column. Next, we have to specify the rebar material for longitudinal and confinement bars. Let's select HYST 415 from the drop-down list for the longitudinal bars. Similarly, we have to specify the rebar material for confinement bars as well. Note that the drop-down list displays only the material which we have defined. If in case we require the material grade which is not present in the drop-down list, we can add it by just clicking on this button, then it will access to the Define Materials window. Now click on Add New Material. Let's add mild 250 grade material, which is according to Indian region, and the material type is rebar, and from the grade, select mild grade 250 and then click on OK. These are the properties of mild 250 grade steel and then click on OK. Now mild 250 grade steel has been successfully added, then click on OK. Now we can find that material in this drop-down list. We can select it now. Specify the reinforcement configuration and confinement bars. As required, under Check Design, here we have to specify whether the concrete frame design post-processor has to check or design the reinforcement. Here you can find two options, namely reinforcement to be checked and reinforcement to be designed. If we choose reinforcement to be designed option, then all information in the reinforcement data is used except bar sizes, which is ignored, and the total required steel area is calculated. Let's select reinforcement to be designed. Next, under longitudinal bars, we have to specify the details like clear cover for confinement bars. Here we have to enter the distance from the edge of the column to the outer face of the confinement bar. For columns, the standard clear cover is 40 mm. Let's enter it. Now we have to specify the number of longitudinal bars along 3 direction and 2 direction face. I'm just taking the same values which are present here. Here the 3 and 2 are the faces parallel to the local 3 and 2 axis. Next is the longitudinal bar size and area. Here we have to specify the size of the longitudinal bar. From the drop-down list, let's take it as some 12 mm. Then it will automatically calculate the area of the bar. Similarly, we have to select the size for the corner bar. Let's take it as same as 12. These two options are optional. These two options are not mandated if you are choosing reinforcement to be designed. Similarly, we have to enter the data in the confinement bars as well. Specify the confinement bar size. And also specify the spacing and number of confinement bars along 3 and 2 directions. After giving the required data, then just click on OK. And then cross-check the details once and then click on OK. Now we can find the section created in the properties area. Similarly, now let's create rectangular concrete beam of size 350 by 300. Click on Add New Property. A window with the name Frame Property Shape Type will be displayed. In this, select the shape type of the frame section either from the drop-down list or from the frequently used shape types. Here I am selecting the rectangular from the concrete. Then in the frame section property data form, specify name of the property in the first box as B350 by 300 and then select the concrete grade in the material from the drop-down list. Let's select M30 grade concrete and then select concrete grade in material from the drop-down list. I'm selecting here M30 grade concrete. Now we have to specify the section dimensions as per the requirement. Enter the depth as 350 mm and width as 300 mm as per the example. And click on Modify Show Rebar under Reinforcement. Here specify the design type as beam and specify the longitudinal bars and confinement bars material. I'm just taking HYST 415 for the longitudinal bars and mild 250 for the confinement bars. In cover to longitudinal rebars group centroid, specify the rebar cover at the top and bottom of the beam. The top cover is a measure from the top of the beam to the centroid of the top longitudinal reinforcing. The bottom cover is a measure from the bottom of the beam to the centroid of the bottom longitudinal reinforcing. The standard clear cover for beam is 25 mm. Let's assume the cover to be entered here as 31 mm by assuming 12 mm dia longitudinal bars at the top and bottom. So the cover becomes 31 mm. And this region is used to enter the reinforcement area for ductile beams. If we want to design any ductile beam, then we can enter the details in this region. After giving the required details, click OK and then click on OK. Now we can find the beam section created in the properties area. Just below to add new property, you can find an option called Add Copy of Property. This is used to create a copy of property by using original selected section from the property list. Next is modify show property. This will allow us to review or modify the selected section property without adding a new section property. Here you can find an option called delete property. This is used to delete any property which is not required. Just select the one and then click on delete property. It asks for the permission to delete. Just click on yes. Then that particular property will be deleted. If you want to delete multiple properties, just click on this delete multiple properties. Then it will pop up a window where you can find the various properties that which are present. Now you can select the property that which you would like to delete by dragging the cursor and then click on delete selected frame sections. Those properties will be deleted. If you click on OK, the action which you have performed will be saved. If you click on cancel, the action which you have performed will not be saved. It means that you will get back the deleted properties. Look at this. The properties are as it is. They have not deleted. Then finally click on OK. Here ends the process of adding frame sections, that is beam and column. We can cross-check from the Model Explorer whether the beam section has been created or not. Maximize the properties by clicking on the plus symbol in the Model Explorer and then maximize the frame sections. Look at this. The properties that which we have created is present here. Now let's see defining the process of a slab section. Go to Define menu again. Select section properties from the drop-down list and then select slab sections. Immediately a window pop-ups with a name slab properties. In the left side region, it displays the default slab sections. Here we are having two default slab sections. To create a new slab section, click on add new property. Immediately a window pop-ups naming slab property data. In this we have to specify the details of slab. Let's take an example of creating a slab section of 125 mm thickness. Specify the name of the property. Here I have given the name as slab 125 for the easy identification purpose. Next is to specify the slab material. Click on the drop-down arrow and select the grade of the concrete required to be considered in the slab. If the required material is not present in the drop-down list, you can add it by using the button beside to it. Here I am selecting M30 grade concrete. And the remaining options are the same, and the next option is same as discussed earlier. Now we have to specify the modeling type. If you click on this, it will display a drop-down list which contains 4 modeling types, namely shell thin, shell thick, membrane and layered. A slab section can have shell thin, shell thick or membrane behavior. Shell type behavior means that both in-plane membrane stiffness and out-of-plane plate bending stiffness are provided for the section, and membrane type behavior means that only in-plane member stiffness is provided for the section, whereas layered, it contains multiple layers each with a different material, thickness, behavior and location. For a general RCC slab, we can prefer shell type modeling. In shells, we have two types, that is shell thin and shell thick. Shell thick modeling type is preferred when the slab thickness is greater than span by 5th to span by 10th of the slab. Shell thin modeling type is preferred when slab thickness is less than span by 5th to span by 10th of the slab. As the thickness of RCC slab is usually less, so in the maximum cases shell thin is preferred. So let us choose shell thin. If you want to add the modifiers in any specific case, click on Modify Show and add it. You can also change the display color by clicking on this change option. And similarly, to add any note or description to the slab, we can add it by using property notes. Next, select the type as slab in the property data form. And then finally, specify the thickness of slab. Let's edit the value as 125 mm. And then click on OK. And then finally click on OK. Now you can find the Define Slab section in the Model Explorer. Just click on this maximize symbol at the slab sections. Look at this. The slab 125 has been successfully created. Below to the Add New Property, you can find an option called Add Copy of Property. This is used to create a copy of already existing slab property. Highlight a property name in the slab property area and click Add Copy of Property button to display the slab property data form and add a new definition to the model file based on the selected property definition. Next option is Modify Show Property. Highlight a section name in the slab property area. Click on Modify Show Property button to display the slab property data form and review or modify the selected property definition without adding a new definition to the model file. Next option is Delete Property button. Highlight a section name in the slab property area and click on Delete Property button to remove the selected property definition from the model file. It will ask for the permission. Just click on Yes. Now that selected section has been deleted. This is about creation of slab section.